Class, this mini lecture is taking a look at different air masses, and we'll take a look at the big storm that goes across the United States called a mid-latitude cyclone, and then we'll end up talking about two fronts that are part of that mid-latitude cyclone. Now, when we're dealing with air masses, we're really looking at a couple attributes of the air. The first one has to do with how warm or the temperature of the air. Now, air that is really warm, we're going to consider that a tropical type of air you see here, and it's going to be given a uppercase T. Now, in terms of cold air, we have cold air, polar air, and then super cold air called Arctic air. So those are the descriptors to determine the temperature of the air mass. Now, the other characteristic that an air mass is sort of embodying would be is the air either wet or is the air dry. And so the two terms, one is maritime, you can see given with a little m, and then we have continental, which represents the dry air. So then you take a look at the different abbreviations. MP stands for maritime polar, and in Southern California, that would be a wet and cool air mass that would bring us rain. And then more of our common air that we have is maritime tropical, which is sort of humid and warm. And then this pattern here is of the winter. We really have a lot more of a summer pattern. But as you look at this location around the Great Lakes, this is actually like where I grew up. Every once in a while, we did have this on our house, and we had to shovel the snow off the top. Not very common, but you can see that as the air moves across these lakes, this side has lake effect snow. And let's move on and take a look at some of these different air masses that we might see in the summer. So in addition, in the summer, we've got this continental tropical air. And this actually gets a little bit larger, and it'll move over the Southern California area. And that type of air is both warm and it is dry. So you can see that there are a variety of different air masses, and these air masses bump into one another. And that collision point is called a front. And so you can have a maritime tropical air mass next to a continental tropical air mass. You can have a continental polar air mass next to a maritime polar air mass. And as these begin to bump into each other, you're going to have what's considered a front. Earlier, we talked about the jet stream. This top air here is considered the jet stream. We've also talked about high and low pressure centers. Here's the high, air is spinning out of the high in a clockwise direction. Air is spinning into a low in a counterclockwise direction. Now what you notice is for this low pressure, it's an area of divergence. It's also considered somewhat of a trough. And you've got these common symbols, which are the different air that's being pulled down. So here, air is being taken from the north and moved to the south. So this is the example of a cold front. And you can see the air moving from the sort of south to the north, creating this red with semicircles, which is called a warm front. So let's take a look at this storm. So that low pressure storm that we just saw really looks like a big comma, and it is sort of a cyclonic movement. So it's called a mid-latitude cyclone because it is in the mid-latitudes. And these move from the west to the east, being pulled by the jet stream. And along with it, you're going to have this movement of these fronts. And so again, to review the two types of fronts that we see in a large storm system, the first front that moves through is the warm front. What's characterized by a warm front is you have these cirrus clouds, really high clouds, then you have some cirrostratus clouds, and then you have some altostratus clouds, and then you possibly have some nimbostratus clouds. And then there's some rain right before the warm front passes your location. and then maybe a day later, depending on maybe 2 days later, you possibly could have a big thunderstorm come through your area as the cold air from behind pushes that cold front through the same area. And so you have these huge cumulonimbus clouds that create that particular storm. So that just gives us a little bit of a base to understand not only air masses, but also fronts and mid-latitude cyclones.